Hi everyone. So in this slide, we are going to see already in the last slide we completed the total chapter. Okay. So in this slide we are going to see the uh, how the questions they will ask from the each topic. Okay. So in the next only 1 or 1.5 month is there for exam board examination. Okay. Now, so we'll see the how the way of question they will ask from the each topic. These are the topics that we need to cover in the carbon and its compounds. Okay. So only these many topics are there, around 6 topics are there here. Okay, the topics are remaining part is deleted for the exam purpose. Okay, for the academic year, for academic year to 2021 to the 22 academic year of class 10th CBSE. So only this topic are there. Okay, so we need to cover the only these topics. Okay, and we'll see what type, how the question they'll ask from the each topic. Okay, so actually from this chapter, they'll ask a 2-mark question. It means in one 2-mark question, they'll ask in terms of 1 question. That means AB means A carries 1 mark, B carries 1 mark. Totally that question carries a 2-mark questions. Okay, and also they're asking the 3-mark questions. It means so they may ask a long question or they will ask A B C. It means A carries 1 mark, B carries 1 mark, C also carries 1 mark. That means totally the question carries a 3 marks. Okay. Now, it means we need to study in terms of 1-mark question, in terms of 1-mark question. Why? Because so 2-mark question they're asking the in 2-mark question they're asking the 1-mark question. Same way in 3-mark question they're asking the 1-mark question, 3 questions they're asking. Okay. If you see the sample paper, they're asking in terms of 1-mark question for 3 marks. Okay. So from this chapter, we get a 2-mark, one 2-mark question, one 3-mark question. Okay. And this is the topics that we need to cover. Okay. Now we'll see how they will ask questions. Okay. Now, first topic. So bonding in carbon and covalent bond. Covalent bond. Okay. First, so they may ask about the what do you call as definition of the covalent bond. Okay. Suppose they may ask about the define covalent bond. Simple question, the 1-mark question. So what do you mean by a covalent bond? A bond is formed by the sharing of electrons, by the sharing of electrons. Sharing of electrons between 2 atoms. Okay. So covalent bond forms by the sharing of 2 electrons. It's a simple way of question 1. Okay. And they may ask, okay, what is the physical state of covalent compound? Okay. So they may ask question, what is the physical state of? What is the physical state of covalent compounds? Covalent compounds is also possibility. So the physical state of covalent compounds, either they exist in the liquid state or in gaseous state. Okay, is the physical state of the covalent compounds. Okay, from this covalent compound. Okay, or they may ask question, why so covalent compound possess low melting and boiling point? There is a possibility of asking question like 1 mark. Okay, so why covalent compound or carbon compounds have a low melting and boiling point? Why? Because weak force of attraction. Because of reason is that weak forces of attractions. So between the molecules. This is the reason we can give for this. Okay, between the molecules. Weak force of attraction between the covalent molecule. Okay, because of that reason they will possess a low melting and boiling point. Okay, so actually covalent compounds are formed by the sharing of electrons. Because of the sharing of electron, they won't give rise to any ion formation during the molecule formation. Okay, they won't give any ions. Okay, so because of the absence of ions, okay, so the force of attractions are very, very weak between the molecules. Okay, so because of the weak force of attractions, a covalent compound or all carbon compound possess low melting and boiling point. Okay, So this is the reason we can. Okay. Next, they ask question, why the covalent compounds are poor conductors of electricity. This is also a possibility of question. Why why covalent compound possess why covalent compounds are very poor conductor of electricity? Why? Because so covalent compound formation, so there is no formation of charges. Okay, no charge formation, no charges formation. There is no charge formation. There is no charge formation. So during bond formation, Why? Because the covalent compounds are formed by the sharing of covalent bond is formed by the sharing of electrons. Okay. So reason is that because of this, there is no charge formation. Okay. If there are no charges, there is no ions. Now, automatically they will possess a very very poor conductors of electricity. Okay. Reason is that there is no charge formation during the bond formation. Okay. So just why? Because the covalent bond is formed with the sharing of electrons. Sharing of the electrons. Okay. These are very small type of questions. Okay. Now, so these are way of questions they will ask from the covalent bond. Okay. Now, from the bonding in carbon, so they may ask question, why carbon do not form C4 minus ion, or why carbon do not make a bond by the formation of C4 plus ion, or they'll ask question, why carbon do not forms bond by the transfer of electrons, If you see the carbon atomic number 6, if you see its electronic configuration K2L4. Okay, so carbon required 4 more electrons to get a octet configuration. Okay, so for getting the octet configuration, carbon cannot gain 4 electrons for getting the octet configuration. At the same time, carbon cannot lose 4 electrons for getting the noble gas configuration, helium configuration. Why? Because so carbon cannot form C4 minus. Why? Because so it is very difficult to those 6 protons to hold the 10 electrons. Okay, it won't form. At the same time, carbon cannot lose 4 electrons. The process is very high energy required process. Okay, so that's why carbon do not form bonds either by gaining electron or by losing electron. Okay, so carbon always forms bonds by the sharing of electrons. Okay, so carbon always forms bonds by the sharing of electrons. That you have to keep in mind. Okay, by the sharing of electron, it can make a bond. It means carbon will make always covalent bonds. Okay, carbon will make always covalent bonds. Now, next. So next important thing is that so it will form a covalent bonds always by the sharing of electrons. Okay. Now, so from here, so they may ask questions. Draw the Lewis dot structures of the different compounds. Okay. For example, so along the carbon there are other elements also will form a bonds by the sharing of electrons. That is hydrogen, oxygen. These are the molecules formed by the sharing of electrons, and nitrogen. Okay, and chlorine also. Okay. Sometimes there is a possibility of asking the Lewis dot structures of these molecules. They'll ask a Lewis dot structures. There is a possibility of asking the Lewis dot structures. Okay, should be thorough with the Lewis dot structures of these molecules. Okay, so I'll show you some of I will take the nitrogen molecule. I will show the how to draw the Lewis dot structure. Okay. So in this molecule, two nitrogens are there. Okay. So you should have a small idea about the electronic configuration of the nitrogen. Okay. Its atomic number 7. Okay. And its electron atomic number 7. Its electronic configuration K2 L5. There are 5 valence electrons. So that 5 valence electrons only we can arrange as a dots around the nitrogen to write the Lewis dot structures. Okay, so nitrogen required a 3 more electrons for getting the octet configuration. Yes or no? So that's why each nitrogen shares three electrons, three pair of electrons to attain the octet configuration. Okay. See, each nitrogen shares a 3 electron pair with. Okay, and if you draw the circle like this. Now see, here nitrogens each between the two nitrogens, 3 electron pair is shared. Okay, so by that each nitrogen acquired a octet configuration. Okay, here 3 electron pair is shared. That's why triple bond forms between the nitrogen molecule, between the nitrogens. Okay, so remaining 2 electrons is the lone pair electrons. Okay, so this is shared pair electron. Okay, so this pair is we can call as a shared pair electrons. Okay, so whatever is seeing this pair electrons we can call as a lone pair electron. Lone pair electrons. You can call as lone pair electrons. Okay. Now, so here 3 shared pair electrons are there. Okay. So by the 3 shared pair electrons, you will get a triple bond. You get triple bond. Okay. So be thorough with the how to draw the Lewis dot structures of the these molecules. Okay. Along that, you should be thorough with how to draw the Lewis dot structure of the carbon compounds also. Okay. Should be thorough with this. Okay. For example, so I will take one example from this topic only. Okay. So the last question. Draw the Lewis dot structure of methane. The starting carbon compound. Methane. Okay. So methane. So we know the carbon tetravalency. 4 valence electrons in here. Yes. Okay. So atomic number of carbon 6. So K2 L4. These are the 4 valence electrons. These 4 valence electrons only we use for writing the Lewis dot structures. Okay. And you see the nitrogen atomic number 1. So it have 1 electron indication. Okay. So it too required a 1 electron for getting the helium configuration. And carbon required a 4 more electrons to get octet configuration. That's why carbon share 1 electron with 4 hydrogens. 1 electron with 4 hydrogens like this. Okay. So by the share, so here also the bond formed by the sharing of electrons. Okay. So carbon shared 4 electrons with 4 hydrogens. By that, carbon attain a octet configuration, and each hydrogen also acquired a doublet configuration. You see the doublet configuration. They acquired a doublet configuration. 2 electrons. They got it. Each hydrogen got a 2 electrons. That is what you can call as doublet configuration. Doublet configuration. Doublet configuration. Okay. So there is a possibility of asking the questions. Draw the Lewis dot structures. Confirm the last question for me. Okay. Draw the sum of the Lewis dot structures of carbon compounds. Okay. So like methane. Sometime they'll ask, so this is the methane. You have to remember the names also. Carbon tetrachloride, CCl4. So its name is carbon tetrachloride. Okay. So carbon tetrachloride. So here also, if you see the carbon, already we know carbon valency 4 electrons are there. It is K2L4. If you see the chlorine, atomic number 17. So K2L8 M7. Okay. So chlorine also required 1 electron for getting the octet configuration. Okay. So for getting 1 electron, so this chlorine will share one electron with the, if you see the chlorine's Lewis dot structure. Okay. We have 4 valence electrons. See, 7 valence electrons. So these are Lewis dot structure of chlorine. Okay. Now, so each chlorine required. So here are 4 chlorines are there. Each chlorine required one electron required for getting the octet configuration. Okay. So that's why. So these 4 chlorines share electrons with this 1 electron with the carbon. 4 electrons of carbon. Okay. So like this. Okay. Here carbon. So we know carbon have a tetravalence. Okay. So carbon share 1 electron with this chlorine. So 1 more electron with the other chlorine. Okay. And 1 more electron with the other chlorine. See, so this is the Lewis dot structure of carbon tetrachloride. See, so by that, chlorines attain all chlorines attain a octet configuration. You see, all chlorines attain octet configuration. So allowing that, carbon also attain the octet configuration. You see, you can see the 8 electrons here: 1, 2, 3, 4, 5, 6, 7, 8. Okay. So these are Lewis dot structure of chlorine, carbon tetrachloride. Okay. So these are about the. So from the topic 1, that is, so bonding in carbon and covalent bonding. So these are the some sample questions. Okay. So the way they have asked questions from the first topic. Okay. Should be thorough with the Lewis dot structures. Okay. Now, so next we'll see second topic, that is what type of questions we'll get from the second topic, that is the unique nature of the carbon. Okay. From here we'll see. Next we'll see in the second topic what type of questions we'll get from the second topic. Okay. That is the unique nature of the carbon. So unique nature of the carbon. Okay. So what do you mean by unique nature now? So out of 180 elements in the periodic table, we have we have in the periodic table around 180 elements we have. Okay. Out of that 180 elements, so carbon have a special properties. We will show the special properties. Okay. Carbon can able to make a n number of compounds, and all compounds are very, very stable compounds. Okay. It can give a very, very long chain compounds. It will give a branched compounds. It will give a ring type of compounds. Okay. And also it can give n number of compounds. Okay. So carbon have a unique nature when compared to the other. So 180 elements of the periodic table. Okay. So first they will may ask question. So what is the reason? So what is the reason? What is the reason why the carbon can able to form a large number of different types of compounds? Large number of carbon compounds. Okay. So to that, there is only 2 reasons we can give. Okay. For the versatile nature of the carbon, there are 2 reasons are there. Okay. So one is the catenation. One is the catenation ability. Okay. So remember this. They may ask question, what is the reason for carbon will make n number of carbon compounds? Okay. So one is the catenation ability, and second one is the tetravalence. We should remember this main reason. Tetravalency. Okay. So carbon have a tetravalency. It can able to make a 4 single bonds. Okay, 4 bonds it can able to make. So by the sharing of 4 electrons. Okay. Now, so this is the 2 reasons we should give for a why carbon can able to form a n number of carbon compounds. Okay. So sometimes they'll ask question, what do you mean by catenation? One more question. They ask question, what do you mean by catenation? Okay. So carbon can able to make a bond with the other carbon, other similar carbon. Okay. So carbon can be able to make bonds this by the sharing of electron bonds with the other other carbon. So to give a long chain, to give a long chain. It also will give a long chain also. Okay. So what do you mean by catalytic ability? Now, carbon can able to form a can able to make a bonds with other carbon. So that ability we can call as a and also will give very long chain also. It also will give very long chain, not a short, not a short chain with the 2 or 3 atoms. Right? It also will give very long chain also. That ability we can call as a catenation. Okay. So no other element have this property except carbon. So no other element have this property of catenation. Okay. So carbon can able to make a chain compounds with other carbon. It also will make a branched compounds with other carbon. It can also make a ring compounds with other carbon. It can able to make a carbon-carbon double bonds and long chain. It can able to make a carbon-carbon double bonds also. It can able to make a carbon-carbon triple bond and also will give very long chain. Okay, so these many properties are there with this carbon. Okay. No other element other than this carbon in the periodic table to show this property. Okay, so that property we can call as a catenation. So you should remember this one. Why means you have to give this answer. Okay, sometime they'll ask question. So name other element of carbon family will shows some extent of catenation. Okay, so under the carbon family, so there is one more element there. There is a silicon. Okay, they have some extent of catenation stability. So this carbon, silicon, this carbon, this silicon. So with the help of the hydrogen, can able to make a chain up to 7 or 8 elements in the chain. Okay, so it will make a chain with hydrogen. Okay, up to 7 to 8 elements, up to 7 to 8 elements. Okay, and that too, these compounds are very reactive, not stable. So this silicon compounds are more reactive, Okay. So because of that, so it can't form a stable compounds. Okay, so silicon cannot form a stable compounds. Okay, you have to remember this. So in the carbon family, there is one more element there, but its catenation ability is very shorter, but it won't give any stable compounds. Okay, not a stable compound. They are not a stable compound. Okay, because of more reactivity. But carbon can give a stable compounds, very stable compounds. Okay, the last question. Okay, they will give very stable compounds. So why? Because carbon have a small size, small size. Okay, and also it can able to hold the shared electrons very strongly. Okay, sometimes they'll ask question, why carbon can able to form a stable compound. So reason is that carbon size is smaller size and it can able to hold the shared electrons very strongly. So very strongly it can able to hold. So because of that, it is able to form a very stable compounds. Okay. So this is the reason you have to give for this. Okay. Next, tetravalency. Tetravalency is the second reason why under the unique nature of the carbon. Okay. So it can able to form a 4 bonds. Okay. So because of tetravalency, this carbon can able to make a bonds with hydrogen and also make a bonds with oxygen and also make a bonds with nitrogen, sulfur, phosphorus. Okay, and also will form a very strong bonds also. Okay, so carbon can able to make a bonds with this because of tetravalency. It can able to make a bonds with the hydrogen, oxygen, nitrogen, sulfur, phosphorus, and also chlorine also, and also halogen family. Okay, that is 17th group. 17th group elements. Okay, under the 17th group we have a fluorine, bromine, iodine. So carbon can able to make a bonds with this compound, this heteroatoms also. Okay, they can also make a very strong bonds also. Make a very strong bonds. Okay. Now because of tetra balancing. Okay. So there is chance of asking questions from here also. Okay. So be thorough with this one, this topic. Okay. Next. So when come to the saturated, okay, next. Okay. Before going to the topic here, carbon can able to make a single bond. Carbon single bond. Okay. So then that compound we can call as a, so here we go with this topic. So what do you call as saturated and unsaturated carbon compound? Okay. From here also there is a possibility of asking some questions. Okay. So what do you call as saturated? Sometimes they may ask question differences. They may ask the differences. Difference between, okay. So difference between saturated and unsaturated carbon compound. They may have differences. Okay. So remember, saturated carbon compound have only single bonds. Only carbon single bond. Carbon single bonds. We have only carbon single bonds. Okay. So what about unsaturated carbon compound? So they have a only double bonds, carbon double bonds, or only carbon triple bonds. Okay. So this unsaturated carbon compounds contains only carbon double bonds or only carbon triple bonds. Okay. So sometimes they'll ask question. You have to give this type of regions. Okay. Next. So we can give a carbon single bonded compound. Best example is alkanes. Okay. So alkanes. So the general formula is CnH2n plus 2. Okay. The alkane general formula or saturated carbon compound general formula of one of the alkanes. Okay. Sometimes they will ask what is the general formula of alkanes. Okay. Give the first two members of the alkene or first 5 members of the alkanes. So from this general formula we can able to write. Sometimes they ask you the first 2 members of the alkane family. Okay, that is CH4, where n is the number of carbon atoms. Remember, number of carbon atoms. Okay, so first one is CH4, when number of carbon 2, that is C2H6 is the second member, and C3H8 is the third member, and C4H10 is the fourth member of this alkane family. Okay, they have a carbon single bond. They have completely carbon single bonds. Okay, clear? So whatever I wrote here, these are the molecular formulas. These are molecular formulas. Okay, molecular formulas. Okay, so this also we can able to write an extent form, that is okay. That is C2H6 is the molecular formula. Okay, its structural formula is, so already we know it is the carbon single bonds are there. Okay, so this is the structural formula of C2H6. Okay, this is the structural formula. Okay, so same way we can able to write the other compounds also. Okay, sometimes they will ask question, give the first 2 members of the alkane. By using the general formula, we can able to use. Okay, same way. So if the saturated carbon compound contains only carbon double bond, we can call as alkenes. Okay, so this alkene have a general formula of CnH2n H2. Okay, this is the general formula of alkene CnH2n. Okay, Sometimes they'll ask question, write the first two members, first member of alkene. What is the first member of alkene? That is where the number of carbon atoms 2. Why? Because we need to make a double bonds. Okay. For making the one, at least one double bond, we require two carbons. Okay. So first member is C2H4. Okay. Is the first member of the alkene family. Alkene family. Okay. Its name is ethene. You ask question. What is the first member of alkene? The first member. Okay. Second member is C3H6. Either propene. Next, third member C4H8. This is butene. So like this, you can get. They may ask question: first member, second member, or third member. Okay, with the first member of alkenes. Same way, unsaturated carbon compound contains carbon-carbon triple bond. We can call as alkynes. Alkynes. Okay. So first member of alkynes, the general formula is, first we'll go with the general formula, Cn H2n minus 2. Okay. So by varying any other number of carbon atoms. Okay. So first member of this family is C2H4. Okay. This is the first member of this alkyne. Name is ethyne. Name is ethyne. Okay. So there is possibility of asking questions. What is the first member of alkyne or alkene or alkene? So you have to remember this one. Okay. So this is the first member of alkyne, that is ethyne. Second member is propyne. C3. So C2H2 is ethyne and C3H4 is the propyne. Is the second member. First member, second member. What is the third member? C4H6 is the butane. The butane. Okay. So this is how to remember this. Okay. They may ask question: what is the first member, second member, or sometimes third member also they will ask. Okay. Now, so sometimes they may ask difference also. Just to write the differences. Saturated carbon compound contains only carbon-carbon single bond. Unsaturated carbon compound, they contains either carbon-carbon only double bonds or only triple bonds. We give some examples for here. Okay. So along that, when you burn, so when heat saturated carbon, if you do the flame test for saturated carbon compounds, this saturated carbon compound will give a non-shooty flame. Non-shooty flame. They give a non-shooty flame. Okay. So what is the non-shooty flame? It will give a clean blue flame. It will give a clean blue flame. Okay. So when you see this unsaturated carbon compound, they give a shooty flame. They give a shooty flame. Shooty flame, yellow flame. Yellow, and it is a dark, somewhat dark, yellow dark flame, and it will deposit black ash on the metal surfaces. Okay. So yellow, this flame will contain some smoke. It contains some smoke. Okay. So that smoke will deposit the black layers on the metal surfaces. Okay. So this is some of differences. Okay. Sometimes they may ask a Lewis dot structures of this all from the alkene family, from the alkene family, that from the alkane family also they may ask some questions. Okay. So we'll see the Lewis dot structure of, now I'm going to draw how to draw the Lewis dot structure of the this ethane, and ethyne. Okay, I will draw some Lewis dot structures. So now we'll see how to draw the Lewis dot structure of some of the saturated one. I will take one saturated carbon compound, and I will take a two unsaturated carbon compound. Okay. For example, if I take one unsaturated carbon compound, that is ethane. Sometimes they'll ask question. Draw the Lewis dot structure of ethane, that is C2H6. Okay, simply there are two carbons. Okay, so each carbon have a tetravalency. Okay, so here, so each carbon share one electron for making a single bond. Remaining 3 electrons they will share with the hydrogens. Okay, here. So this is the Lewis dot structure of ethane. Okay, so this is the Lewis dot structure. Okay. So if you see the Lewis dot structure, so this is the one. You can see here, this is the Lewis dot structure of ethane. Ethane molecule. Okay. So here, one electron pair should be shared between the two atoms. That's why you will get all single bonds: carbon, carbon, single bond, carbon, hydrogen, single bond. So all are single bonds here. Okay. Why? Because one electron pair is shared here. Only one electron pair is shared. Okay. With the structure. Okay. Same way. If you see the Lewis dot structure of ethene, molecule is C2H4. Okay. Here, so in ethene molecule, so two electron pair is shared between the two carbons. Two electron pair is shared between the two carbons. Okay. So remaining one electron is shared with the hydrogen. Remaining two electrons are shared with the hydrogens, like this. Okay. So this is the Lewis dot structure of C. So between the two carbons, two electron pair is shared. Okay. So by that each carbon attain the octet configuration, and the hydrogens acquired a doublet configuration. You see. Okay. So here two electron pairs shared between the two carbons, that is double bond and forms. So remaining between the carbon and hydrogen single bond. Why? Because one electron pair is shared there. Okay. Here the structure and Lewis dot structure of ethene. Same way. If you go for a ethyne molecule, ethyne. Okay. So formula, molecular formula is C2H2. In ethyne, between the two carbons, three electron pair is shared. Okay. And remaining one electron is shared with the hydrogen. With the hydrogen. Okay. So this is the Lewis dot structure of ethyne. Ethyne. So by that, so three electron pair is shared here. The way triple bond will forms. Okay. And between the carbon and hydrogen single bond. Why? Because one electron pair is shared. Okay. So these are the Lewis dot structure of ethane, ethene, and ethyne. Okay. So definitely they'll ask some question from here. Okay. Like a differences they may ask, or they may ask the Lewis dot structures. Lewis dot structures. Okay. So these are way of question they'll ask from this topic. Next we'll see the from chain branched ring compound, what type of question they'll ask. Okay. So from here, maximum they'll ask questions, that is draw the structural isomers. From this topic, mainly they'll ask about the structural isomers or structure of compounds. Okay, we'll see that also. Oh. Now we'll see how the question they will ask from a 4.2.2. Okay, so mostly from here they'll ask a draw the possible structural isomer. They'll ask question like this: draw the possible structural isomers by giving isomers by giving one compound. They will ask a possible structural isomers. Okay. So basically, they will ask. They may ask from the alkenes. From alkenes. Okay. For example, C4H10. Okay. C4H10 is one of the alkene. So that is C4H10. We can call as a butane. Okay. So we wrote this one by using the general formula of CN H2N plus 2. Okay. Either general formula of alkanes. By using that, we wrote the butane. Okay. Now, Now we'll see the what are the possible structure isomers of from this molecular formula. Okay. Now in the molecular formula, so C4 has to be the molecular formula of butane. Either molecular formula of butane. Okay. Now, so if you see this butane, in two ways we can able to arrange the carbon chain. Okay. So one is we can arrange the carbons in straight chain, in chain form. Okay. We can arrange them in the straight chain, in the chain form. Okay. So in the remaining places we can arrange the hydrogens. Okay. We can arrange in straight chain. Okay. So here there is one possibility of structure by this molecular formula. So everything here in this case, every carbon is straight. Okay. You see here, carbons are in straight. Okay. This is one way of arranging the possibility. Next, the second possibility, we can also make a branches also. Branch one. Okay. Carbon we can able to arrange in the form of branches. Okay. Now, remaining places we can arrange the hydrogens. Arranges hydrogens. Okay. Carbon tetravalence should be satisfied. And then we have to arrange the hydrogen. Okay. Now see the both the compound have a this compound have a same molecular formula, and they have a different structure. Okay. At one place the structure is chain. Okay. Here the chain. It's the chain compound. It's the branch compound. Branch. Okay. Both have the same molecular formula but different structure. Okay. So then that we can call as structural isomers. What do you call as structural isomers? So structural isomers are the isomers. Isomers are the compounds, are the carbon compounds have same molecular formula, molecular formula, but differing structural formula or structural formula. Okay. Then these two compounds we can call as structural isomers. Okay. So any two structural isomers, okay, if you take any two structural isomers, they will show same chemical properties, but shows different physical properties. Okay, this you have to keep in mind. Any two structural isomers, they will show a same molecular form, same chemical properties. Why they will show the same chemical properties? Molecular formula is same. Okay, and they will show the different physical property. Why? Structure is different. Physical properties always depends upon the structure. Okay, chemical properties depends upon the molecular formula. Okay, molecular formula. Okay, so same chemical properties. Why? Because same because of same molecular formula. Why the isomers will show different physical properties? Differ in the structures. Different structure. Because of this different structure, they will show a different physical property. Okay. By taking other example, I will explain here. Okay. For example, I will take a compound that is C3H6. C3H6O. Okay. So the other compound C3H6O. Okay, the one of alcohol. This is one of the alcohol. Okay. So this is alcohol here. Now, how we wrote this alcohol? Alcohols. So I have general formula CnH2n plus 2O. This is alcohol general formula. Okay, CnH2n O. Sorry. So this is aldehyde, sir. CnH2n O. Okay. Sorry, this is aldehyde general formula. Okay. General formula of aldehydes, but alcohol general formula is, so we can able to see, we can put in the, so if in number of carbon atom 3, automatically 6. Okay. So the aldehyde general formula, aldehyde or ketone general formula. Okay. Now, so sometimes they'll ask a question. Draw the structural isomers. Structural isomers. Okay. See, so what is the structural isomer? Same molecular formula but different structure. You got to think about it. Same molecular formula, different structures. Okay. Now, suppose we can arrange that 3 carbons. Okay. So is the aldehyde group now? So at the end there is an aldehyde group. So remaining places you have to keep the hydrogens. Okay, with aldehyde. So we can't change the chain. Only one possibility there. There is only one possibility to draw the only one possibility there to draw the structures. Okay, you don't have any other possibility. Okay, so that's why we can't draw the structural isomers from this molecular formula. So number of structural isomers are 0. Okay. So with same formula we can also write the ketone also. Okay, with aldehyde, ketone also we can write with a ketone. Ketone also we can write. Ketone also we can write. So from the ketone also we can't try any structural isomers. Here also number of structural isomers is 0. So what do you call as structural isomers? Have same formula, different structure. Okay, but so with same formula but different compound with different functional group. Now these two we can call as the functional group isomers. Functional group isomers, but they are not a structural difference. Okay, so we can able to write the functional group isomer. In the 10th standard, there is no, they are not given the functional group isomers. Just they ask a simple chain isomers. Chain isomers. Okay. So having same formula, differ in the parent chain or differ in the structure. Okay. Now, so there's we can't try any structural difference compounds. Okay, but we can able to write the functional group different compounds. Functional isomers we can able to write. So we can able to write a functional. We can able to write a functional group isomers. Functional group isomers. Isomers. Okay, both have same molecular formula but different in the functional group. We can able to write the functional group isomers. Okay, this functional group isomers also we can consider the structural isomers. We can also consider the structural isomers. Okay, we can also consider the structural isomers. Same molecular formula but different in the functional group. We can consider the structural isomers also. Okay, but we can't write the chain isomers like this. Okay, having same molecular formula, different in the structure. But we can't write it. But we can able to write the functional group isomers by using this formula. Okay, so be careful. So they may ask sometime they may ask a high level questions. Okay, so in the CBSE we can't stick to the particular topic. From the particular topic they may ask a high level questions. There is a possibility also there. Okay, so be careful about this topic. So mostly they'll ask. Okay, and try to draw the structural isomers of C5H12. You can able to draw the 3. You try all of it, and you try, you will get a 3 structural isomers from this compound. Okay, so this is about the 4.2.2. Okay, from this topic they will ask this type of questions. Mostly they will ask me. Okay, now from aldehyde, from this general formula we can able to write the 2 functional group isomers. Okay, so next we'll see the next one, that is 4.2.3. so that is a very important topic. We'll see some of the questions there. So next under 4.2.3 is from me. This is a topic also somewhat important topic here. So this is about the functional group. This topic about the functional groups. Functional groups. Okay. So first they may ask question, define the functional group. Okay. So what is called as a functional group now? Element, heteroelement, or group of element. Group of heteroelement means other than carbon and hydrogen. Other than carbon and, so other than carbon and hydrogen. Okay. element or group of elements which possess properties to the carbon compounds, which will possess properties to the carbon compounds. Carbon compounds. Okay. Then that groups we can call as a functional group. That element we can call as a functional group. Okay. So I think we have a, so in the 10th standard they given around 5 functional groups with names also they given. Okay. So first one is halogens family. Halogen. Okay. So halogens will show in terms of X. Okay. Halogen may be chlorine, bromine, or iodine. So mostly they will ask from the here only two by using by these two compounds, by these two elements only they are giving the examples. Okay. Next, alcohols. Okay. OH group is the alcohol. Okay. So next, aldehyde. Okay. C double bond OH. Okay, this is the aldehyde group. Next, ketones. C double bond O is a ketone. Okay. Next, carboxylic acid. Okay. That is C double bond OH. Okay. So from here also they may ask so many questions here. Possibility of asking so many questions. Simple. How they'll ask question? By just by giving some compounds. They give one compound like this. Identify the function group. See what function group is here? C double bond O. Okay. So these are identify, you have to identify the function group and name the function. This is the ketone group. Okay. Now same way by giving other examples. Yeah. So in this compound, what is the function? So this is the function group. There is OH. So just you have to identify the function. There is a alcoholic function group. Alcohol. Okay. So like this, they will ask question from here. Okay. Sometimes they may ask it matches. Match the following. Okay. So like this, they may ask, just they will shuffle the name and groups, name on the group of the function groups. So they ask it just to match the following. So there is a possibility of asking matches also. Matches. Okay, from this topic. So next last one is homologous series. From here also there are possibility of asking a 3 or 2 mark. Three mark question maximum will ask. Okay. So which are called as homologous series. Now first I'll define what is called as homologous series. A series of compounds. First one have same general formula, and second one is differ by 14 unit, differ by CH2 between the two successive compounds, differ by the CH2 between any two successive compounds, or differ by the 14 unit of mass between any two successive compounds. Next, gradation means gradual increase. Gradation in physical properties. Okay. Next, fourth one, I have same chemical properties. Okay. Chemical properties. Okay. Sometime by giving one series, they may ask, so identify whether the series is homologous series or not. Okay. So for that we should remember the, okay, for identify that we have to remember those general formulas. Okay. So alkane general formula, CnH2n plus 2. So alkenes general formula CnH2n. Alkyne general formula CnH2n minus 2. Aldehydes, and ketone general formula. Ketone general formula is CnH2nO. Alcohol general formula CnH2n plus 2O. And carboxylic acid general formula. Carboxylic acid general formula CnH2nO2. CnH2nO2. Okay, the general formulas of some important carbon compounds. Okay, next. Okay. Same way for halogen general formula CnH2n plus 1 X. CnH2n plus 1 X, where X may be a fluorine or bromine. Okay, where X is the fluorine or bromine. Okay, so be careful. We'll see some questions here. So you have to remember these points from this topic. Okay, now we'll see some of the questions. Okay, in grand way. We'll see some questions here. Okay, now see, here we have one compound there. Okay, so from this so like multiple choices we are seeing here. Okay, don't worry about it. Okay, try to understand the content also from here. Okay, now here we have some questions with us. Okay, just we'll see how the, okay, they may ask like a one more question. Okay, and sometimes they'll ask question C3H8 belongs to the homologous series of, maybe without option. Sometimes they ask for a one more question. Okay, so actually this is belongs to the, so this we can able to write in the general formula of CnH2n plus 2 SN, where number of carbon atom 3. Okay, so C3, so 6 plus 2 8. Okay, so this compound we can write in the form of general formula of CnH2n plus 2. That means, so this is the general formula of alkanes. Yes or no? Alkanes. Okay, so this compound belongs to the homologous series of alkanes. So we have to be careful. Okay, next, second one, second question. So from here also they will ask question from the allotropic forms of carbon. Okay, so what do you mean by allotropic? Allotropic forms, no? Same element exists in different forms. So what is the allotropy? No? Allotropic means, allotropic forms means same element exists in different forms. So carbon exists in 3 different forms. In our textbook they given only 3 different forms here. So one is diamond, one is graphite, one is fluorines. Okay, so we have to remember this topic also. Okay, here they will ask one question here. Okay, so in a diamond, each carbon bonded to the other 4 carbon atoms. Okay, forms what type of structure? So it will form a rigid 3-dimensional structure. It will form a rigid 3-dimensional structure. Okay, same way graphite. So in the graphite, each carbon bonded to the 3 other carbons. I'm writing the same question in different way. So graphite. Okay, in graphite, each carbon bonded to 3 other carbons. Okay, forms what type of structures? Okay, so graphite will form a hexagonal layers. Graphite forms a hexagonal layers. Okay, but diamond will form a rigid 3-dimensional structure. Okay, so that's why diamond is very hard, very hard, but graphite is very soft in nature. Why? It will form a hexagonal layer-like structure. Okay, and fluorines will form a football-like structure. Fluorines will form a other carbon allotrope, that is fluorines here. Okay, so it will form a, okay, it will form a structures of football, like a shape of football. Okay, it will form a football-like structure. Okay, so be careful about this. Next, one more question from this topic only. The allotropic form of carbon which is a very good conductor of heat and electricity. Okay, so that is graphite. Graphite is the one which has a very good conductor of heat and electricity. So sometimes they may extend the question like this. Okay, so what is the reason why graphite is a good conductor? Okay, so in the graphite case, each carbon surrounds by the three other carbons, surrounded by the three other carbons, Okay, so tetravalence of the carbon not satisfied, one electron free in the graphite cases, so this free electron, so make the graphite good conductor. Okay, so this free electron make the graphite very good conductor of heat and electricity. That you have to keep in mind. Okay, next. So next one, how many double bonds are there in the saturated carbon compound? Okay, so already we learned what you call a saturated carbon compound. There is only carbon-carbon single bonds, and there is no any double bonds here. Number of double bonds is 0 here. Number of double bonds is 0. Okay, now there is one more. Okay, we will go with the short questions. Okay, so already I told, draw the Lewis. There is a possibility of asking questions. Draw the Lewis dot structure of ethine. So already I drawn it. Once again I will draw it. In ethine, triple bond is there. Okay, so between the two carbons, 3 electron pair is shared, and 1 electron is shared with the hydrogens. Okay, between the hydrogens. So this is the Lewis dot structure of ethine. So I'll draw once again, sorry. So each carbon shares 3 electron pair and 1 electron with the hydrogen. Okay. So this is the Lewis dot structure of ethine molecule. See, definitely the last question here. So 3 electron pair shape, the one is triple bond and single bond with the hydrogens. Okay, with the Lewis dot structure, and it's the next step. So already I told. So identify name the functional group present in the following compound. See here. So in this compound there is a OH group, functional group. So OH means what? So alcohol. Okay. Here you have a C double bond OH. So this is the carboxylic group. Here you have a carboxylic acid function group. Okay, and here you can see the C double bond O. It is ketone group. Okay, and here, so what is the function group here? Double bond is it? So that is double bond. It means is alkene. Okay, just remember that. So double bond, triple bond also they act as a function groups. Why? Because the properties of compound decided by the double bond and triple bond. Okay. Any element or group of element, okay, or bond which will decide the properties of the carbon compound that we can call as a function group. Okay, now same way you see here in the second case also, here we have some more compounds. Okay, so name the function group present in the following. Okay, so here there is CO now what we can call as ketone. Okay, here we have a COOH, carboxylic acid. Here aldehyde, you see the aldehyde here. And here you can see the alkynes, OH. Okay, so these are the some of the, so this is the way of question they'll ask me. Okay, now see here. So carbon is the 14th group element. Yes, we know. Okay, and it is known to form a compounds with many elements. Yes, it can able to form. Write some of the examples of compounds formed by chlorine and oxygen. Chlorine and oxygen. Okay, suppose chlorine with halogen. Already I gave the general formula. Cn H2n plus 1 X. Okay, where X is the chlorine, you have to take care. Chlorine, where X is chlorine here. So by taking this general formula, write the sum of the compounds. Okay, you can write like C, if number of carbon 1, that is C has 3, Cl, first compound, and also we can write C2H5, Cl, second compound, C3H6, H7, C3H7, Cl is the third compound. Like that we can give it. Okay. Next, with oxygen also it can even make bond. Okay. So with oxygen we can have it three types of functional group we can form. That is alcohols possible. Okay, we can write the alcohols. Okay. So alcohol general formula is Cn H2n plus 2 O, or we write again Cn H2n plus 1 OH. Okay, these are alcohols. First we write the CH3OH first compound and C2H5 second compound. So like that we can give them some example. So just you have to remember the general formulas. Then you can able to write. Okay. Now same that is repeated question. Next, what do you call as hydrocarbons? You see the question here. What do you call as hydrocarbon? Give some examples. So what do you call as hydrocarbons now? A carbon compounds. A carbon compounds which have only carbon and hydrogen. Which have only carbon and hydrogen. Okay. So best example is alkanes and alkenes and alkynes. This is the best example of this. Okay, you can give some example. Okay. Now, so give the structural difference between the saturated and unsaturated carbon compound. Okay, with two examples. Okay. So already we know saturated one have a single bond, carbon-carbon single bond. So they may have a double bond or triple bond. Okay, you can use some example for this. So this is the way of asking question. Next. So these are draw the electron dot structure of carbon tetrachloride. Already I told you. So carbon tetrachloride. So this is the carbon tetrachloride's Lewis dot structure. Okay. Carbon tetrachloride. So Lewis dot structure. You can write like this. Okay. So just to draw the the way to draw the Lewis dot structure of carbon tetrachloride. Okay. Now, next one. So they're asking question. So by giving the draw the possible isomers by using this formula. Okay. And also give the electron dot structures. They're extended like this. Okay. So by already I gave this one is the aldehydes. So aldehyde, one of the aldehyde. Okay. So we can able to write the functional group isomers with this. Okay. Functional group isomers that is CH3, CH2, C double bond O is the aldehyde. And ketone also we can write this with there. With help of this, we can write the ketone. Okay. Ketones. So both are having same formula but different in the function group. They also will come under the isomers. Okay, what type of isomer? Such isomers will come under the structured isomers. Okay, so they're asking the Lewis dot structure. So just I'll draw here Lewis dot structure of the aldehyde. Okay, so here so this carbon make a bond with other carbon like this. Okay, so this is the okay. So this is the Lewis dot structure. Just you want to draw the Okay. So Lewis dot structure of this aldehyde. Same we can able to write the ketone also. Same. At every bond case, you put the one two dots. Okay. So your one bond now, two dots. Okay. Here two bonds now, two pair. Okay. Oxygen. Okay. Here is other carbon. Okay. So this carbon made a bond with other three carbons, three hydrogens. Just to put the three dots. Okay. Here hydrogen, two dots. Okay. There is other carbon here. Okay. Here one hydrogen, here hydrogen. Okay. Just to draw the circle. Okay. So this is the Lewis dot structure of this ketone. Okay. The Lewis dot structures. Okay. So try to study like this. You can get a very good marks in this carbon and its a compound chapter. Okay. Thank you. Have a nice day.